Okay, in this video we evaluate the integral of dx over x plus 1 over x squared from 0 to infinity. We can do the following. This equals to from 0 to infinity of dx over. Now in the denominator we can have x times x is x squared plus 1 over x all squared. And this equals to from 0 to infinity dx over x squared plus 1 squared over x squared. Now dx over x squared plus 1 squared over x squared equals to from 0 to infinity x squared over x squared plus 1 all squared dx. Now notice that if we add 1 to x squared in the numerator, we can cancel it with this square of x squared plus 1. But if we add 1, we have to subtract 1 also. So we can do the following. From 0 to infinity, we have x squared plus 1 minus 1 over x squared plus 1 all squared dx. Now we can split this into two fractions. So this equals to from 0 to infinity x squared plus 1 over x squared plus 1 all squared dx minus from 0 to infinity 1 over x squared plus 1 all squared dx. Now the first part we have first from 0 to infinity of x squared plus 1 over x squared plus 1 all squared dx. This equals to from 0 to infinity 1 over x squared plus 1 dx. And this equals to tan inverse of x from 0 to infinity. And this equals to pi over 2 minus 0 equals pi over 2. This is part 1. Now part 2 we have from 0 to infinity 1 over x squared plus 1 all squared dx. If we let x equals tan theta, then dx equals secant squared theta d theta. So we have now, notice also for the limits of the integral, when x equals 0, then theta also equals 0. And when x equals infinity, we have theta equals pi over 2. So now we have 1 over, and now x equals tan theta, so tan squared theta plus 1 is secant squared theta all squared, and dx equals to secant squared theta d theta. Now this equals to from 0 to infinity to pi over 2. Now this secant squared theta cancels out with this, so we are left with 1 over secant squared theta, which is cosine squared theta d theta. Now using one of the trigonometric identity, this equals to from 0 to pi over 2 half of 1 plus cosine 2 theta d theta, and this equals to 1 half of theta plus 1 half sine 2 theta. This is from 0 to pi over 2, and this equals to 1 half. When theta equals pi over 2, we have here pi over 2 plus now when the upper limit is pi over 2, then 2 pi times pi over 2 is pi, and sine of pi equals 0. This is minus, when lower limit is 0, we have here 0, plus sine of 2 times 0 is 0, and sine of 0 equals to 0. So we have here pi over 4. So therefore our original limit equals to the first part, which is here, pi over 2, minus this part, which is here. So this equals to we have from 0 to infinity of dx over x plus 1 over x all squared equals to pi over 2 minus pi over 4, and this equals to pi over 4, and this is the final answer.